All right, let's actually do some calculations now. So we're asked to use Cramer's rule to solve the following systems of linear equations. So this first system, I'm just going to start off by making it into an augmented matrix. Using our coefficients, we got 1, negative 2, dash, 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 dash. For the constants, we got negative 11. And then our second row, we got negative 3, positive 3, and 12. And again, I'm just going to highlight our constants to help us remember that those are going to be what gets canceled, or what replaces other things. So to find our x's, that's a highlighter, sorry. To find our x's, we're going to do d sub x over d. Now I'm just going to do the denominator first. The denominator is just the coefficient matrix, or the determinant of the coefficient matrix. So just that left side. So we got 1, negative 2, negative 3, 3. For the d sub x, again, d sub x, we replace the x coefficients with our constants. So we're going to replace it with negative 11 and 12. We're going to replace the x's with that. And then the y's still stay the same, negative 2 and 3. So again, to highlight that, these constants replace the x coefficients. Now to actually calculate this, we're going to do the diagonals. So we're going to do negative 11 times 3 minus 12 times negative 2. For our denominator, it's going to be 1 times 3 minus negative 3 times negative 2. Cleaning that up a little bit, we got negative 33, and then minus 12 times negative 2. Well, 12 times negative 2 is negative 24, so that's plus 24. In our denominator, we've got 3 minus negative 3 times negative 2 is positive 6, so it's 3 minus 6. Cleaning this up just a little bit more, negative 33 plus 24 is negative 9. 3 minus 6 is negative 3, and negative 9 divided by 3 is 3. That's not too bad. All right, for the x's, sorry, for the y's, my apologies, we're going to do the similar thing. We're going to do d sub y over d. Now, we already did that denominator using that coefficient determinant, which as a result, we already know what that's equal to. That denominator is already equal to negative 3. We don't need to do that again. The numerator, we're going to replace the y coefficients with our constants. So our y column gets replaced with our constants. Just to repeat that, that's where that comes from. Now the x coefficients, we're going to use the original ones of 1 and negative 3. So now when we do the determinant of that numerator, we have 1 times 12 minus negative 3 times negative 11. 1 times 12 is 12. Negative 3 times negative 11 is 33, so it's 12 minus 33. All that still divided by negative 3. 12 minus 33 is negative 21 divided by negative 3, which gives us our y solution of 7. So our final solution, we get an x of 3 and a y of 7. Not too bad, just a different way of setting it up. For our last example, we're going to do the similar thing. Again, I'm just going to write the coefficient, or sorry, the augmented matrix. We've got 4, negative 1, negative 7. And then our second column, or sorry, second row, my apologies, is 1, 3, negative 5. So for our x's, again, it's d sub x over d. I tend to do the denominator first just because it's the left side of that augmented matrix. It's 4, negative 1, 1, 3. And then for our numerator, again, for d sub x, we replace the x column with the coefficients. Sorry, with the constants. My apologies. So we replace the x coefficients with the constants. So we're going to do negative 7, negative 5, and then we're also going to still have those y values, those y coefficients. So again, we replace the x's. So for our numerator, we're going to do negative 7 times 3 minus negative 5 times negative 1. For our denominator, our first diagonal is going to be 4 times 3 minus our second diagonal of 1 times negative 1. For our numerator, negative 7 times 3 is negative 21 minus negative 5 times negative 1 gives us positive 5. So negative 21 minus 5 over our denominator of 4 times 3 is 12 minus, minus 1 times negative 1, so minus negative 1 or plus 1. So we got negative 26 over positive 13, which gives us negative 2. For the y's, again, we got y equals d sub y over d. Now, d, we already did that one. I'm going to rewrite that matrix as 4, -1, 1, 3. And then our numerator d sub y, we're going to replace the y coefficients, the second column, with our constants. So we got a -7 and a -5 there. And then our x's, our coefficients stay the same. So for our numerator, we're going to have 4 times -5 minus 1 times -7. And our denominator, again, we already did that determinant. We did that in the previous one. It's simplified all the way down to just 13. Now, 4 times -5 is -20, minus, we got 1 times -7, so minus -7, which means plus 7. And that's being divided by 13. -20 plus 7 is -13. Divide that by 13, we got -1. So our solution there, our x value is -2, our y value is -1.